Today we are going to demonstrate how to find out the Young's modulus of the material of the bar. Here we have a steel bar. So by the method of flexure. So in your theory classes you have already studied this. So the expression for the Young's modulus is given by GL cube by 4BD cube capital M by L, where capital L, this is the length of the bar. This is not the length of the bar. This is the length from between the stirrups. From here we have marked over here and we have marked over here. So we have to keep in mind that this should be exactly in the center, right? So here we have taken 1 meter. And this is the 50 centimeter mark, and the gap over here and the gap over here, these two should be same, right? So now we have hung the stirrup from the middle. We have to find out the breadth of the bar and the depth of the bar. Now the breadth of the bar, it appears in first power, and the depth of the bar, it appears in the power of 3. So the breadth of the bar, the depth of the bar needs to be measured with much more accuracy. So what we will do, we will measure the breadth of the bar using a slide calipers. So I think by the time you know how to use a slide caliper, so I am not demonstrating that. First you have to find out the vernier constant, which our case is 0.01 centimeter, and then you have to find out the main scale reading. So in this case the main scale reading is 2.5, and then you have to see the vernier, which vernier division coincides with the main scale. So we'll find that out, that which vernier division coincides with the main scale. Sorry, it's 2.6 for the main scale reading, and for the vernier it is 2. So the total reading comes out to be 2.62 centimeters. So the total reading will be the main scale reading plus vernier scale reading into the vernier constant. So we have found out. Now this should be found out at 3 places of the bar, because the bar might not be uniform. So we have to do this, repeat this procedure in at least 3 places of the bar. Now let's come to finding out the depth of the bar. We will find out the depth using a screw gauge. You already know how to use a screw gauge. We have already demonstrated that in the practical classes. So what we will do, we'll take this screw gauge and we will find out the least count. So least count of this screw gauge is 0.001 centimeter. So least count is basically the screw pitch by total number of divisions. Here the total number of divisions is 100, and the screw pitch is 1 millimeter. So the least count counts to be 0.001 centimeter. So we will just fix the screw gauge over here, and then we will find out. So we have to do this using this screw, and when it is fixed, this will give a false click, as we can hear over here. So once we know this gives a false click, we know that the reading, this is perfectly done. So now we will read the main scale reading. So the main scale reading over here is 7 millimeter, 567 millimeter, and the circular scale reading, the main scale reading is 7 mm, and the circular scale reading, if we see, it is 8 division. So thus we can find out in this case also the total depth of the bar. Likewise, the depth of the bar also should be measured in at least 3 positions, because the bar might not be uniform throughout. Next, what we do, so this can be done by removing the bar from the stirrup. So it is not necessarily that this has to be measured keeping the stirrups in point. Keeping the bar on the stirrups. You can just remove the bar and measure it as well. So the next we do that the length of the bar we have taken here to be 1 meter. It can be repeated for other data also, say 90 centimeter, 110 centimeter. But it is to be kept in mind that on this side and that side the bar should be symmetrically placed on the stirrups, and this one it should be placed exactly in the middle. So if this is 1 meter, this should be 50 centimeter. Next what we do, here now there is no load on the hanger. Now this is a traveling microscope. This traveling microscope has a circular scale over here and a main scale over here. Here it works on the principle of the circular scale. Not here we do not have any vernier reading. We have a circular scale over here. So here also we will measure the screw pitch. So the screw pitch, it is found to be 1 millimeter and there are 100 divisions. So the least count is in this case also 0.001 centimeter. Now first what we have to do, we have to focus this pointer and we have to focus this pointer and we have to see that it coincides with the crossware at any point on the crossware, right? And when this is done, we will measure the reading over here. We will measure the main scale reading and the circular scale reading. So this is the reading when there is no load on the hanger. So that is mass is 0 kg. There is no load on the hanger. So there we will measure the main scale reading and the vernier scale reading. So we can see here the main scale, it is reading, it is about 2.3. The main scale reading is 2.3 centimeter and the vernier scale reading or the circular scale rather, this is not the vernier scale reading, the circular scale reading is about 11. So the circular scale reading is 11. So from here we can find out the total reading. Now what we will do, we will place a half kg weight on this hanger. So when we will place the weight on this hanger, the beam will bend and this pointer, it will go down. So we have to use this circular scale to again make this pointer come to the crossware, coincide with the crossware, and we will measure the reading in this case. But you have to keep in mind that you should give some time for the bar for the depression, because if we place the weight and simultaneously take the reading, then the reading will not be stable. So you should give at least 2 to 3 minutes time for the hanger, like after 2 to 3 minutes after hanging the weight, then we will take the reading. So let me place the weight on the hanger. This is a half kilo weight. Now as you can see over here, the pointer, this pointer, it has shifted from the crossware. So what we need to do, we need to move this circular scale. Let's just let it stabilize for a moment. Let's just stabilize it for a moment, and then we will move this circular scale. We have to look at this and we have to move the circular scale to again bring that pointer to the crossware. So it is oscillating a bit, so maybe we can wait for a few moments and then we can take the reading. So likewise in the similar way, now the reading is, in this case, 2.2. The main scale reading has changed. The reading is now 2.2, and the circular scale reading over here, this is 60, this is 70, this is near about 63. This is near about 63. And this is 2.2 centimeter. So likewise we will keep on putting weights, say in steps of half kg. So first half kg, then 1 kg, 1.5 kg, 2 kg, 2.5 kg, and then we will keep on taking the readings, and we will repeat the entire procedure while removing the weights as well. We will remove weight one by one, and we will measure the readings, and we will compare the two, and we'll average the while load increasing and while load decreasing. We will get two set of readings, and then we will average the two, and then we will find out the depression. The depression is basically the difference of the reading from the initial data when there was no load. So when there was no load, say that if the reading is X, and if the subsequent readings after putting loads be Y1, Y2, Y3, Y4, then it will be, the depression will be Y1 minus X, Y2 minus X, Y3 minus X, and so on and so forth. So now if we plot the load on the x-axis and the depression on the y-axis, it will be a straight line from which we can find out the value of the Young